Okay, what we have here is part of a 2007 Cobalt powered door lock system. Now this is just the BCM looking at the user input. So this is only a portion of the entire door lock system, but this is the part we're going to look at today. So we're simulating as best we can with this software the BCM over here on the left and the door lock switch over here on the right. Now this doesn't matter in this case if it's the driver's side or passenger side because they are in parallel. So the passenger side would just be a parallel circuit off of this. It would operate all by the BCM looking at this one line coming into it right here. So what I've got inside the BCM is a simple breakdown of how you just need to look at it, how you want to look at it simply, so you understand how this circuit works. How does the BCM know that you're not pressing the switch or you've requested the lock or the unlock? It can monitor those three states on one line. And what it's basically doing is monitoring the voltage on that line. So what we've got here is a voltmeter inside the BCM, so that simulates what the BCM is seeing, and the readout is right here. And you have your voltmeter, and I've got various voltmeters placed in different sections of the circuit. So when we activate some faults, I've got fault 2 here and fault 1 here. It gives you a better understanding of what's going on. So I'm just putting multiple voltmeters in here. You would only need one, and you would just walk around to that point in the circuit. So this type of circuit, it's not just for this '07 power door lock on the Cobalt. It is ubiquitous. This type of circuit is and can be used anywhere. It's a very basic, how can we monitor what's going on with a user input in 3 different states. And this is how GM chose to do it in 2007 power door lock system, but you'll find this type of circuit everywhere. So you learn this and you've got a lot covered. Now I will mention this door lock switch isn't exactly like most vehicle door lock switches, but in this particular piece of software, it's a little on the old side, it's a little klutzy. It doesn't have the switch I need. So I've just made 2 separate switches, but understand I will operate them as if they were, the actual switch that you would be looking at. But understand this schematic here is wrong, but I'm going to make sure it operates exactly like you would see it. And as a reminder, this is just the user input thing. So we're not going to deal with the output end of the relays and the power door lock actuators. This is just the input. So the BCM sends out 12 volts. Think of it just going through a resistor, and then it comes out, and this is what you, the user, have access to. This line out here, you don't have access to anything inside. But what you see on this line is going to be what the BCM sees on this line, barring any faults. So that's why I put this there so you can see it. So when the system is on, you are not pressing the lock or the unlock, and there is no fault in this system. The BCM reads the nominal 12 volts on this line inside. Now you're on the outside right here monitoring the voltage at this pin, either of the BCM end or the door lock switch end, and you will read the same voltage. So that is 12 volts there. Now whether I'm pressing the lock or unlock, this voltage here will change, and that's what's going to signal to the BCM, what is the user doing. So you can see here on the inside of this door lock switch, the lock portion just sends that line straight to ground. So everyone should understand what this voltage on this line, or this voltage of this voltmeter, is going to be when the user presses the lock function of the switch. And on the other portion of this door lock switch, when you press the unlock, it goes through a resistor inside the switch. You don't see it, and it comes out, and they share this common ground. So in order to be able to diagnose circuits like this, you need to know how this circuit works, and you need to know what the value of the voltmeter is that you should be reading when the circuit is operating properly. And if it's giving you another reading, a reading that it shouldn't be giving you, that's a sign. That's going to tell you what's wrong with the circuit, or at least it's going to start pointing you in the right direction, and a couple more steps down the road you'll find the fault. But you have to understand what this voltmeter is saying to you, and it doesn't speak in your language, it speaks in volts. And then you convert it into your understanding of what's going on in the circuit, given the voltage that you're reading. All right, so let's see how this should work when the vehicle is working properly, when there are no faults. So when we press the lock, you're going to get 12 volts here, and I want you to pause the video and think of what this voltmeter should read, and as well as this one over here. We're just connected onto the ground side over here before you proceed ahead. Because if you know what these voltmeter readings should be, then you're well on your way to understanding the circuit, and you're able to properly diagnose it. So when we go to lock, right, so we press the lock here, the voltage inside is driven 4 microvolts, 2.7 microvolts. That's effectively 0. Right? So this line is driven low. It's now connected straight to ground. So the BCM, it was previously 12 volts. That's telling the BCM you're not touching the switch at all. Now when you go to lock, this line goes low, goes to 0 volts. The BCM knows when it sees 0 volts there, you must be requesting the lock. Okay, now let's go to the unlock. And what you can see here is you've got this resistor here inside. And if you follow the circuit, it's going through and it's going through another resistor. Now, it is likely somewhere around that 900 ohms for this particular vehicle. Not that that matters. What matters is this resistance is going to match this resistance, and then it's just going to go straight to ground. If you have that internal resistance matching this one, and you're checking the voltage in between the two resistors in series, it will split the available voltage approximately even. So you should be looking for something close to 6 volts on that line when the user has requested the unlock. And 5 volts would work, 6, 7, doesn't have to be exactly 6, but you see what we're getting at here. Once the BCM sees something that's not 0 and not close enough to 0, or not 12 or not close enough to 12, in and around that 6 volt, there's going to be a range so you don't have funny operations. That BCM is going to assume you've gone to the unlock. So it will unlock the door locks. So you can see 12 volts, 6 volts, and 0 volts are the 3 different states that this BCM sees. And if you look at the basics of this circuitry, you're going to understand on which mode, lock, unlock, or not pressing it, you're going to get those various voltages. Now let's move into the faults for a second, because this is where you're going to have to use your brain a little bit. So let's just assume, I've got fault 1 here. Let's just assume, we don't know it of course, but this ground is bad. So we're going to open this ground. It's open. Now when you're sitting here like this, you don't know that there's even a problem, because when you're not pressing the lock or unlock, it's going to be 12 volts. The BCM sees this, you see this over here, you wouldn't even know. Now let's go to lock. When we press the lock, you'll notice this stays high, this stays high. There is no path to ground. So when you're pressing lock and you've got 12 volts here, you know there's a path to ground that's been opened. Now listen, it could be inside the switch, it could be after the switch on its way to ground, or the ground itself is bad. You don't know that, but you do know you have lost your path to ground. Now let's try, how should this look when we hit the unlock? So you're going to see it's the same, where this path to ground does not exist, and you're going to read 12 volts here. And I should mention, you'll notice that this voltmeter here, which is why I put it here, it's going to read 12 volts as well. So you could actually put this voltmeter here over on this side, and you would read that 12 volts as well. But stick to measuring this side here until you see what's going on in the 3 states, and then it will tell you which way you should go, further downstream, further upstream. So I don't want to confuse you, but you can see that this voltmeter right here, prior to the fault, is also going to read 12. And it's the same when we lock. It's still going to read 12. Remember, because this voltmeter on the ground side is before the open. Okay, so now let's take a look. Let's reset fault 1, and we're going to take a look at fault 2. Now, if fault 2 was open, the voltage you would read with your voltmeter at the door lock switch on this pin, you're going to notice that the BCM sees 12 volts because we've got an open outside of the BCM on its way to the door lock switch. And the door lock switch, this line, which should read 12, is reading effectively 0 volts. there's an open between the BCM and this door lock switch. And now you can see it doesn't matter what you do. If this line is 0 volts, you can request the lock, it's just 0. You can request the unlock, it's still 0 volts. And this fault, if it's open, you wouldn't know it. It's still all 0 volts. There's nothing there. This whole circuit from the open down to the ground is just 0 volts. And we'll reset this fault number 2, and you notice we have our 12 volts back. All right, so that's a brief explanation of how the BCM knows what the user is doing, and it is a function of reading the voltage on that line. And you just either put the downstream end of this switch straight to ground, or you run it through a resistor, which drops the voltage. So it's very, very simple.